right, so subnet mask. Subnet mask is a very important notation that allows us to recognize whether there are two hosts exist on the same network or not. We have tried that before, if you remember, when we talked about ARP or Address Resolution Protocol, and we have tried to recognize whether there are two hosts that exist on the same subnet or not. So the way to do that is to convert or to AND the host address with what we call a subnet mask. A subnet mask is represented using repeated ones, as we can see here. So these are repeated ones until, so consecutive ones, a consecutive set of ones, and then the rest will be zeros. So for example, 255.255.255.0, that's a subnet. If we put 255.0.0.0, that's also a valid subnet. If we put 255.240, for example, .0.0, as we will see later that this is also a valid subnet, and so on. So the way that we calculate whether a particular address lies in a particular subnet or not, the way to do that is by ANDing the IP address with the subnet mask. This way we can isolate or separate the network portion from the host portion. So, so for example, this IP address 192.168.10.10. If the subnet mask is like this, 255.255.255, then what we do is that we represent each one in binary, and then we AND those two parts. And then, if we AND those two parts, this means that this number will stay as is, and the other part will be all zeros, as we can see here. So this way we can separate the network part from the host part. So this is the way that we calculate the network part using the subnet mask. Another way of representing the subnet mask is using what we call network prefixes. So in network prefixes, we represent the subnet mask as a prefix length, as opposed to using the notation 255.255.255.0. So instead of doing that, because this number is simply all ones for 24 bits and the rest will be zero, so we can simply represent the same number here using the notation /24. So /24 here represents 255.255.255.0, and this way we can omit the long notation of subnet mask. So for example, this number here, or this address is 10.1.1.0/24. That means that the host address is 10.1.1.0, and the subnet mask is actually 255.255.255.0. So without having to represent the subnet mask using this long notation, we can represent it for short using this small notation. So this example here explains how to isolate or separate the network address from the host address. So this is the address that corresponds to a particular network, and if we have a network that has the address 1.1.0/24, this means that the first 3 bytes, the first 24 bits, are the network part, and this part can change to represent each host. So in this network, the hosts will start from 1 all the way to 254. There's no 255 here, as we will see in a minute. There's no 255 here to correspond to host address. So in that example, the first host address will be 10.1.1.1. So this in this byte changes to 1, and the last host address will be 10.1.1.254. There's no 255 because 255 is a special address and it corresponds to broadcast address. So if we set the address to 10.1.1.255, this means that we send to all hosts in this subnet. Similarly, we can calculate the network address that corresponds to this particular address. So remember here is that 25 consecutive ones. So this means that this byte will be split into 2 parts. The first bit will be part of the network address, and the last 7 bits will correspond to the host address. So you only have 7 bits to correspond to the host portion. So in that case, the host portion will start from 1 all the way to 0, 1, 1, 1, 1, 1, 1. And this is actually 126. Because if we set this to 1, so that means all ones, and all ones here will correspond to the broadcast address. And remember, here we have only 7 bits, not 8 bits like in the first example. So similarly, if we do that example here, we have only 6 bits. So this byte will be split into 2 parts. The first part is that you have 2 bits that belong to the network, and then the last 6 bits will correspond to the host. So the host can start from any, so 1 and all zeros, all the way to 0 here and all ones. And in that case, 0 and 5 ones here correspond to 62. So the 62 is the last host address. If we put this to 1, this means that the host portion is all ones, and in that case, it represents a special broadcast address that we cannot use to assign to any particular host, and in that case, it's the broadcast address. So these talk about many examples that explain this notion. So we can do the same thing here for 27, and in that case, we have only 5 bits for host, and the rest will be network. And in that case, we end up with 32 different IPs. The first one will be 1 to represent the host, and then 30 will be the last host address, and then if we put all ones, that's 31, and that one corresponds to the broadcast address, and so on. So we can train ourselves how to calculate the network address, the host addresses, and the broadcast address given any IP address and network prefix. So for any IP address and network prefix, this is how to calculate the network address. So the network address here corresponds to the IP address that's used by the router to route to a particular network. Host addresses are addresses that can be assigned to particular hosts, and then broadcast address is a special address that will be used by any host to broadcast to a particular subnet. So for example, in this network here, we have a network address which is 10.1.1.0/24. So in that case, host addresses can get any address from 1 10.1.1.1 all the way to this number here, which is 10.1.1.254. And if any of these hosts want to send to all the other hosts, then this host will use the special address, broadcast address, which is 10.1.1.255, which is the broadcast address, and so on. So the first host address can be calculated easily by setting the host portion to start from 1 and then all zeros to range from zeros and all ones. So if you put 1 and all zeros, you will start with the first IP address for the first host IP address, and then if you put 0 and all ones, this is the last. So this is the first IP address for a host, and this is the last. And remember that you have a particular size for the host portion to represent the host part and to represent the broadcast. In this way, you can calculate the first and last addresses for a host. So here that explains the AND operation, and I assume that students are familiar with the ANDing operation. So if we AND 1 and 1, the result will be 1. Otherwise, if we AND 1 to 0, the result will be 0, or 0 to 1, the result will be 0, or 0 to 0, the result will be 0. So this is how to AND the IP address with the subnet mask in order to isolate the network part from the host part, and then we take this host part and then we use all possible combinations. So if we start from 1 all the way to zeros, or zeros and ones and all the way ones, so that gives us the first and last IP address for host, and then if we set it all ones, that's the broadcast address, as we have explained before. So that exercise explains how to calculate the network address from the host address. So if we were to have this host address here, 10.154.120.151, using the subnet mask 255.255.255.128, and this is a valid subnet mask because actually 128 is 1 and then all zeros. So that corresponds to 1 and then 0, 0, 0, 0, 0, 0, 0. So that's consecutive ones, and that's a valid subnet mask in this case. So the way to do that is simply by converting the 10, which is this binary combination, and 154, which is this binary combination. So we need to convert all the octets into binary, put the subnet mask like this, and then AND. So if we AND this with this, the answer will be simply 10, so which is the same. So 0, 0. So that corresponds to 0, 0, 0, 0, and then 1, 0, 1, 0. And then this will not change as well. So, and then we have to be careful in this one here. 1 ANDed with 1 is 1, and then the rest will be zeros regardless, because the subnet mask has consecutive zeros in that case. So in that case, it should be 0, 0, 0, 0, 0, 0, 0. And then we convert this back into decimal, so that's obviously 10, and that's obviously 154, so that does not change, and that also does not change. And then we have to be careful. So 151 will change and become 128 because this is 1 and then 0. So let's see and hope that this is correct. So that's correct. And so on. So here, this is another example, and we can see that only the byte that's not 255, we need to be careful when we calculate or we perform the AND operation. So for example, this byte here is 240. So obviously, this part of the address will stay the same, this part of the address will stay the same, and this part of the address will stay the same, and only this part we need to be careful. So 240 is actually 4 ones and 4 zeros, and 239 is actually 3 1s 0 and then 4 1s, and in that case this will be here 1 1 1 and then all zeros, 2 2 4. So that's 2 2 4, 1 1 1 and then all zeros, that's 2 2 4. So you can calculate that and verify my answer here. I won't click check because we did not fill these parts, but anyway, that should be correct.